This is a piece of rebar. I'm at the beginning stages of having a house built and they're pouring the foundation this week. And under all that concrete, this thing is gonna be full of rebar. I've always known that rebar makes concrete stronger, but until this week, I had never put in the time to research exactly why that is. I spent half a decade in engineering school, which means while I don't have these answers in my head, I am an expert researcher. So I did the research. I now have a complete understanding. I will tell it to you now. Concrete is extremely resistant to compression, meaning you can put a whole lot of weight on top of it without it being crushed. It is super duper strong against a compressive force. But in construction, there are two other types of forces that you need to solve for in a structure. Tension, which is the opposite of compression, or something being pulled on, and shear, a force being applied from the side, causing a slice of the structure to slide off. If you think of pulling an Oreo cookie apart, you'll be using a combination of tension, pulling the cookie apart, and shear, twisting the cookie to do that. Interestingly, concrete is very weak at resisting both tension and shear forces on its own. I've made a couple of different concrete beams and I'll be demonstrating that in a minute. Other than resisting compressive force, another thing concrete is extremely good at is gripping things that it's poured around. That's why you can use it to secure a post to the ground. You can put a post in a hole and then fill that with concrete and they will basically never let go. Rebar is this stick made out of tempered carbon steel with a bunch of little ribs and knobs stamped into it. Carbon steel, unlike concrete, is super strong under tension and shear forces. This is more or less the same type of steel that's used in the springs that support your car, basically holding up thousands of pounds and being able to withstand being ranked on a few 100,000 times throughout its life cycle. Some genius a long time ago figured out that if you set a framework of this steel into the form of whatever thing you're going to make out of concrete, a bridge, a road, a statue, a foundation for your house, whatever, the concrete will handle all of the compressive forces and keep the thing in its general shape. And since it can grip onto all these little nubs on the rebar, it will transfer all of the shear force and the tension to the steel that's embedded in the concrete. These two substances together make a very strong building material. To add to these fellas being a perfect match, steel and concrete have a very similar thermal coefficient. Part of what that means is they will expand and contract with the temperature at about the same rate, allowing them to coexist in any climate for a prolonged period of time. For a concrete beam, or even something like your garage floor, when something heavy drives across the top of it, the top half of the beam is trying to cave in on itself, so it's under a compressive force. But you'll notice the bottom half of the concrete is trying to be ripped apart. It is under tension. And therefore, if you happen to be present when someone is pouring load-bearing concrete, you'll notice that the rebar gets placed way down towards the bottom of the form, because those compressive forces at the top will be handled by the strength of the concrete, but the rebar will tackle all the tension at the bottom. Most concrete things eventually develop cracks. Evidently, that doesn't necessarily mean that the structures become weaker, because with a crack in the concrete, let's just say this was one solid piece and there's a giant crack across the middle now, it can still hold just as much weight pushing down on it. That doesn't matter. But obviously by pulling up, they would separate. When a crack forms on a concrete slab or a beam, the rebar inside is still doing its job. It's still attached to both of these pieces. So if this beam with rebar in it developed a big crack, both sides will still be connected through the rebar. One of the unfortunate things about steel is it's a little springy. It's a little flexible. Concrete is not. So if this flexes too far, the bottom of the concrete will crack, even though the structure may still be sound. Reinforced concrete can crack without breaking. Of course, if that does happen on like a bridge, that would definitely call for an engineer to come check the thing out. Anyway, I took the time to mix up some concrete of my own and pour two little beams, both the same dimensions and poured from the same batch of concrete, but in one of the beams, I set a piece of rebar towards the bottom of the form. The other one is just solid concrete. So for the first test, I actually have no idea how strong these aren't. I've got this 40-pound chunk of solid steel. Why do I have this? I don't know exactly. It seemed like it could be a useful thing to keep in the shop, and I'm not sorry I bought it. Let's start with the non-reinforced beam. Can you hold 40 pounds? Let's find out. No problem. What if I concentrate most of the weight to the middle? Still fine. I planned for this. I've got some weight plates. So now we're looking at 65 pounds. We should move my other one out of the way. 90 pounds. I have a balance issue, but the beam is still fine. Bring out the bigger boy. 40, so this is, what, 90 pounds? Maybe I should have made a thinner beam. 110 pounds. 135 pounds. Hey! With a little help from me, it broke at 135 pounds. Now, let's try that same thing with the steel reinforced beam. I'm all out of weight plates. I don't know how heavy a cinder block is, but the internet will tell me. About 38 pounds. This is 211 pounds on the same size beam. 249 pounds? I think I'm illustrating the point. Although now I really want to try to break this thing, so I'm gonna go find a sledgehammer. Oh boy. I guess I very well might end up breaking the table before I break the beam. Nope, I sure didn't. In the case of this bridge, I hope the engineer orders a bit of a restructuring. I hope this has helped to illustrate why rebar goes into concrete beams. Tension. Goodbye.